You can see a lot by looking, the famous philosopher Yogi Berra said. My corollary, you can find high leverage by taking a bath. Yes, you heard me. Taking a bath or a big soak can be illuminating as well as relaxing. It's high leverage because if you understand how bathtubs work, if you have an operational understanding, you will be better able to develop new market innovations, hire and retain world-class talent, reduce chronic disease, build equity in your workforce and communities, strengthen your relationships, and yes, better understand the dynamics of something as massive as climate change. If you've watched other videos on this channel, for example, the welcome video or the overview of double loop learning, you're aware that this list includes adaptive challenges. And if you've had any exposure to systems thinking, perhaps you've read The Fifth Discipline, you'll believe that the first step to solving these adaptive challenges would be to apply a systems archetype or perhaps develop a causal loop diagram. And I'm here to say that you'd be wrong. Why? Because if you jump from a problem statement directly to feedback loops, you'll miss a huge opportunity for learning and perhaps even miss the requisite double loop learning you absolutely need to solve the problem. This video will show you the fundamental step, the first step you must take to ensure you can double loop learn, to ensure you can find high leverage solutions for your adaptive challenges. And that first step is to apply stock and flow thinking. So you want to make an impact? You want to identify leverage, places where you can make a significant difference? Then you need to apply stock and flow thinking. As I've described elsewhere, high leverage mental models have absolute clarity about two components. One, the behavior you want to change or influence, and two, the structure that generates or drives that behavior. Stock and flow thinking is the capacity to apply bathtub dynamics and is critical to building a clear and operational understanding of the structure. Building a simple stock and flow map often leads to double loop learning. In this video, I'll introduce you to stock and flow thinking, including the basics of stocks and flows, why this thinking identifies leverage, and why it's especially helpful in understanding climate change. Typical mental models are vague, undefined, and abstract narratives that often lack clear causal theories. Stock and flow thinking replaces that fuzzy narrative with an unambiguous declaration of the physics of the system you want to influence. When I'm wrestling with a complex issue, the first thing I do is picture the key stock, or perhaps chain of stocks, that capture the essence of an issue, and then the associated flows. So let's define each. Stock versus flow now. Stocks are the nouns of the systems thinking language. They are accumulations. They are the current level of something. They exist at a point in time, freeze action, and they persist. And they can be physical or non-physical, allowing us to quantify them. To quantify anything. Examples of physical stocks are staff, greenhouse gases in the atmosphere, inventory, acres. Examples of less physical accumulations, stocks that you can't really perceive through your senses, are money in the bank, metadata, songs in my iTunes playlist, farmer debt, leadership skills, trust, burnout, fear. Anything you can quantify that can build or decrease over time can be represented as a stock. One easy way to visualize a stock is as stuff in a bathtub. A stock of inventory is an accumulated level of physical entities, perhaps widgets. If your stock of fear is high, very afraid, then your bathtub of fear is quite full. Stocks exist at a point in time. If you close the doors to your workplace and don't let people enter or leave, your stock of staff in the office can be counted. It's 100% knowable. And if you're into accounting, the items you find on a balance sheet are all stocks. Flows occur over time. They are the actions and activities that change the level of a stock. They are rates of change. They add to or take away from a stock. It's often easy to name them using the ing ending. Items on income statements are flows. Stuff flows through them in the direction of the hollow arrowhead. The nozzle on top indicates the rate may increase or decrease, much like what happens when opening up the nozzle on a faucet. A cloud indicates that whatever is flowing is either coming from outside the current bounds of the system or flowing out into it. Flows associated with stocks previously listed are hiring, emitting, shipping, selling, depositing, accumulating, adding, paying off, building, losing, generating, dissipating. Here's a stock we can all relate to: burnout. The pandemic may have caused this stock to go even higher than we imagined possible. If you want to reduce burnout, you can 1. Reduce the rate at which burnout builds, or 2. Increase the rate burnout dissipates. And these must be so that the rate of burnout building is less than the rate at which burnout dissipates. So what's your strategy? Avoid situations that generate burnout? Increase your ability to not let those situations burn you out? Find ways to dissipate that burnout? Or some combination? We'll discuss these strategies in more depth in a future video. But for now, climate-related stories are no longer out there, out into the future. We've already seen unprecedented heat waves in Portland, Oregon and Seattle, Washington. Over 1,000 deaths in Paris related to heat. And hurricanes are getting stronger and slower and have the potential to create more damage and deaths. The problems seem overwhelming, almost hopeless. Yet, applying simple bathtub dynamics, stock and flow thinking, to climate would be a good first step towards slowing and eventually stopping the increase in global temperatures and avoiding a future we all wish to avoid. Bathtub dynamics are simple. Bathtubs are stocks that fill with water through the inflow, the spout. The water flows out of the stock through the drain. This stock represents the accumulation of greenhouse gases in the atmosphere, a bathtub. Its level rises as more greenhouse gases accumulate in the tub. Greenhouse gases enter the atmosphere through the flow of annual emissions entering the atmosphere. This is usually thought of in terms of metric tons or metric tons of greenhouse gases per year. The ones we're concerned with are generated by human activity, burning fossil fuels, for example. The Earth has natural processes that remove greenhouse gases from the atmosphere as well. For example, trees that sequester carbon as they grow. Here's an outflow of annual removals from atmosphere. Each year, the Earth removes and sequesters metric tons of greenhouse gases. Let's now experiment with this structure. In the stock, you'll see a trend line that simulates the level of the stock out into the future, in this case for 10 years. The vertical line in the center represents the halfway point, year 5 of the decade. All changes in emissions and reductions will occur at year 5 in the following scenarios. Each of the flow regulator icons, the circles, have tiny trend lines in them as well that represent the annual rate for each of those flows. These trend lines also show year 5, so you'll be able to see when any change in rate occurs. In this base case scenario, the inflow rate to the stock is 2 times the outflow rate. This means annual emissions is twice the amount of removals. Look at the location and trend of the inflow line in the left flow icon. Compare that to the outflow line. Although both are level, the annual emissions trend line is at a greater height. With the emissions rate twice the removals rate, the trend line for greenhouse gases in the atmosphere rises linearly across the decade. What do you think will happen if there's a substantial decrease in emissions at year 5? Assume that annual emissions are suddenly cut by 25%. That's a huge all-at-once decrease. What will happen to the future trend for greenhouse gases in the atmosphere? The bathtub continues to fill, just at a slower rate. The line after year 5 rises more gradually, less steeply, but it still rises. Now, what do you think will happen if annual emissions is cut by a total of 50% and is now equal to annual removals? The bathtub levels off at year 5 and remains so indefinitely. Did you expect the level in the bathtub to begin falling? Many do, but that would be against the physics. The only possible behavior for the stock when the inflow becomes equal to the outflow is for the level in the stock to remain constant. This is the concept of net zero. Net zero occurs when the inflow minus the outflow equals 0. If emissions were 50 million metric tons per year and removals were 50 million metric tons per year, then 50 minus 50 equals net zero. What's the only way for the bathtub level to fall? For net emissions to be negative, the inflow must be less than the outflow. Here's an example where the outflow becomes double its initial value and the inflow is set at 25% its initial value. In this case, the level in the stock falls substantially and could become 0 eventually. In the real world, it would take several years of negative net emissions to bring greenhouse gas concentration down to pre-industrial levels. All climate policies are designed to either decrease the inflow, reduce emissions, or increase the outflow, increase removals. you'll find it helpful to think about which flow any given policy is trying to impact. There are some important principles to note. 1. Thinking of greenhouse gas concentration as a bathtub improves understanding of policy. 2. It's possible to significantly reduce emissions to believe we're making an impact while concentration continues to increase. 3. Net zero means the inflow minus the outflow, emissions minus removals, equals 0. This won't decrease concentration. It only means concentration won't become higher. The only way to reduce concentration is for the removal rate to exceed the emissions rate. That's the physics. Use this operational understanding as you discuss climate dynamics with colleagues and friends. And any stock you manage, the same principles apply. To make the stock increase, have the inflow greater than the outflow. To decrease, the outflow must be greater than the inflow. And if they're equal, they'll maintain the stock's level. In future videos, I'll give you more tips on how to use stocks and flows to build understanding. You can use it to understand how to build customer top of mind or manage customer satisfaction. You can use stock and flow thinking to understand developing a highly skilled workforce and managing technological innovation. And stock and flow thinking can be very helpful in understanding polarization and the role of dark money, international politics, and the economy. I'll show you how to link stocks and flows and chains, and how to use and identifying feedback loops. But for now, it's important to note, in order to understand an important issue, it is usually helpful to identify the key stock you need to manage. With that in mind, identify the inflow. Do you need to increase its rate, like in the case of learning or skill building? Or do you need to slow it down, like in the case of building fear? Identify the outflow. Do you need to increase its rate, as in the case of dissipating fear, or decrease its rate, as in the case of forgetting, with skills? And what are the levers most effective at managing those flows? Understanding how to manage a bathtub, although seemingly simple, can hold the key to managing really, really important things.